All right, if we introduce, we have these two objects in the scene. These will act as parents. Okay? And this third object in the middle, that's the child. Again, we're talking about constraints here. Okay, so not a hierarchical relationship, but we're going to do this via constraints. So these two, I called them parents, but in constraint lingo, those are called targets. So if I use these two target objects, lastly, I select the child, or the constrained object, right? And let's bring up the rigging tool set here, and I'm going to apply a parent constraint.
So it's parented to both of them now?
It's parented to both of them, right? Either in my outliner, I can come to the cone, which is that child of the constrained object, and I'll find the parent constraint there in the hierarchy. It puts parent constraints in the hierarchy as children of the constrained object. Or I can just click on the cone. That will also show up here in the history of my object. So here's my parent constraint. These are the same parameters that you'll see if you just click on the constraint itself. You can see at the bottom of that you will have your list of targets. Under this rotation, decomposition, node state, interp type, you'll have the targets. So this is telling me pSphere 1, which is here. That's pSphere 1, and pSphere 2 are targets, or parents, if you will, of the cone, the child. And they both have a weight value right now of 100%, right? That value 1 is 100%. So they each have equal pull on the object, okay? So if I pull object 1 away, you can see I'm getting about a 50%. They're both sharing 100%. They're both set to 100%, but they have to share the total value. So you can see that that cone in the middle, it's getting 50% of the transformation of pSphere 1. And it's not, I did a parent constraint, so that's going to be both rotation and scale. I'm getting 50% of the rotation there too. I'm sorry, rotation and translation. Okay? And I can come over to the other target and I have the exact same effect. Okay? So hopefully that part makes sense, right? They're sharing that relationship, that constraint relationship, those two targets.
Did you have to highlight both of those spheres together?
When I created it?
Yeah.
Yeah, I selected constrainers, the targets first, and whatever object I select last. And I could do 100 objects. I could have 100 targets, right? If I have 100 things selected, then the first 99 will act as targets to the last selection, which will be the actual constrained object. Okay? And that's a great question, and there are other ways to do this. I'm just going to delete this constraint. If I just constrained it to polysphere 1, let's say I had a parent constraint there. All right, so it's just going to follow that one sphere, and if I look at my constraint, I only have a single target. I can go back and add an additional target. So now I can select pSphere 2 and the cone, and I'll add a constraint again, parent constraint. And I don't know if you saw there, just added an additional target. Right, so now it will behave as I showed you before. Should I broadcast this to your computers? Can you guys see in the back? Does that help? Hi, Kyle. Hope you're having fun far away. Michael misses you. Loud sound. Okay, so again, I have two targets that are part of this constraint. Okay, you cool with that idea? Okay, that right there basically is how we do IKFK constraints. Okay, if you can grasp what we just did, you're pretty much most of the way there. Because we're going to be doing the same thing. We're going to have an FK system, we're going to have an IK system as their own separate joint chains. And then we're going to have another system that's going to be blended between either of those two via constraints. Okay, same idea. Just same way that I've got this object, this cone that's I've got a blended transformation between. Maybe I should change one of these objects. Let's do a cube.
basically the cube and the sphere represent the different systems.
Exactly. Exactly. So I'll select those two and do a parent constraint.
Does that mean if you move the hand with IK, you move that handle, the hands only go 50%?
Yes, but we're going a step further. Okay, you're correct. But we can actually fiddle with the weights of the targets. Okay, which is what I'll show you now. So again, right now they're both sharing 100% of the target weight right now. But I can alter this value. Okay, it does not have to be a value of 100. So if I turn P-sphere 1 off, I'm going to take that value down to 0. And I transform the sphere, nothing happens because there's no longer any weight to that constraint. Right? But my target weight for the cube, I still have a value of 1. So it's following the cube completely. Right? And I can change that. I can alter it the other direction. So I'll go back to my parent constraint. I'll bring the cube value down to 0 and the sphere value up to 1. Right? And now I've got an inverse behavior. Now it only follows the sphere, not the cube. Okay? When I first created this constraint, I'm going to go to my options here for my constraint. I've got this maintain offset turned on. I'm not going to want that for my IK and FK systems. Because really when FK is on, I expect the joint chain to be in the exact same position as the FK chain. Right? Or if I turn the IK system on, I expect it to move to and be in the exact same position as the IK system. So when we create these, you just need to make sure maintain offset is turned off. And you'll actually see the behavior is going to be a little bit differently. It's going to behave a little different. I'll select those two targets again. And lastly, that child. All right, I'll add this constraint. You see how it's snapped? Right, so that's snapping to the exactly right between the position of the two targets. And now when I play with these parameters, if I turn P-sphere 1 target weight down to 0, right, now the cube has 100% of the weight. So this not only follows the translation or transformation of the cube, but it does it in the exact same place. Right, so really, other than it looks a little different, the shape's different, the transformation values are going to be exactly the same. Right, and I can move this cube, or excuse me, the sphere, and reposition it and rotate it. And when I change the target weight now, so I'm going to turn the cube off, that's going to go down to 0. Okay, and I'll turn the sphere value up to 1. Okay, and now it will follow the sphere. Okay, we're going to be able to blend between the two. The way a constraint works, if you have a value of 0, obviously it's not going to follow at all. If you have a single target, okay, and it has a value of 0, it's not going to follow. As soon as it gets any value, 0.000001, because there's only one target, it will automatically follow at 100%. That's why it just suddenly popped. It just snapped to the sphere. Okay. When we have two targets, we can actually blend those values, and you will see it. The constrained object will transition from one to the other. So if I have my IK arm locked here onto the monitor, and my FK arm's over here, and I switch between the two, my arm will actually transition between the two systems. Okay? Without me having to animate it, it will just do that for me automatically. Okay? We cool with that idea? Okay. So we're going to come back to that. Really, all that FK-IK switching is doing is we're creating constraints between systems, and we're blending the weights of the targets. Okay? So let's talk about how we can actually blend weights. So far, as far as values of objects go, the only real tie to values we've talked about is constraints. Right? You can alter the constraint of another transformation by constraining it. Okay, so we're going to talk about maybe we'll just do two of them now. Okay. You guys dealt with node-based editors of any kind yet? A couple of you have? Okay. Do we bring up the node editor at all in here? Not yet. Okay, well let's do that. Under Windows, node editor, you're going to get this little graph. Inside of this graph, the navigation is the same as in the window. It's only 2 dimensions, so Alt middle click will allow you to pan, and right click will allow you to zoom in and zoom out. F will frame whatever you've got selected. Okay, those are the big ones. Up here in our toolbar, some useful buttons here. This one with the nice little sparkles is the squeaky clean window, so if I click that, it just erases everything. The one next to it with the plus, whatever I have selected. So I select that sphere and hit the plus, it will add that specific object to my node editor. All right, if I have a couple selected, we'll add both of those objects. And whatever I have selected here in the node editor, I can hit the one with the little minus button and it will take those specific objects out. Okay. Another quick way to add things is in the outliner. I can just middle click drag from the outliner into my node editor. Okay. What the node editor is, it's not just a place to see things, but it's a way to actually view connections between your different objects. So as an example, I'm going to clear this out. So there's squeaky clean again. My parent constraint. If I were to drag this in, I brought in that one object. That's it, the parent constraint. Okay. Right now, I'm not seeing any relationships to other objects, even though obviously there is a relationship between my targets and my constrained object. Okay, so up here in the toolbar again, these 3 icons, boxes with arrows coming in and out of them. So this first one is for input, so any connections coming into that object will be graphed in this node editor. Right, the one on the far right is any connections coming out of that object will be graphed, and then obviously the one in the middle will show inputs and outputs. So in the case of this constraint, I'm just going to graph inputs and outputs. I'll click the one in the middle. That's usually the one that I do. And it gives us a whole mess of things here. Okay, this is showing relationships. So if we decode this, my parent constraint, you can see I've got incoming connections here from P cube and P sphere. Right? Those are those 2 targets. And we can verify this. If you just put your mouse over one of these connecting wires, it will show you what attributes are actually being connected from one to the other. Or you've also got these, I don't even know what to call these little capsule looking things. If you click on these, it will expand to show. So the first one, let's see if I can remember how it works. You see how I just filled in the first box? That's just showing the object and that there are connections. The second one will just show you the attributes that are actually being connected. And if you click it again, that will show you all of your available, let's scan this up, all of the available attributes or parameters that you can connect to other objects. Okay, a parent constraint, when you create a parent constraint, it does all this stuff for you. What it is, we don't have to worry about. It does that for you. Okay, the important thing to notice right here is the parent constraint attributes the target attributes are connected into the parent constraint, and then eventually they are output here to the cone. Right, this is our object that was constrained. You can see there's attributes coming into the translation and rotation of that object.
So does the parent constraint always show the funny S-curve connecting to itself?
Coming back to itself, yes.
Okay.
And that's
Just
some of the
design.
math happening in there. Yeah, yeah. So these are called direct connections. Okay. If we look at, I'm just going to expand this parent constraint a little bit, and I can even expand these values a little bit more. Same with my translates and rotates on my object here. Okay, I've got wires coming out from my parent constraint. There's arrows, it's hard to see which way these are pointing, but they're coming out. The right side is out, by the way. The right side of a node is out. The left side is in. Okay? So I've got translate x, y, and z values from my parent constraint that are coming out, and they're feeding directly into the translate x, y, and z values of my constraint, which one was that, the cone, right? Okay, these are direct connections, which means whatever value is here in this parameter will be the exact same value that is put into the connected attribute, okay? So if this is a value of 5, then this will be a value of 5. This changes to 7, this will change to 7. They're basically one-to-one. They're exactly the same. And this is different. You know, you guys are doing a little bit of coding, you're doing your games. When you assign, like, a equals 5, right, you assign it that value at that current state as 5. If something, let's say that value of 5 changes to something else, your variable doesn't change. It's been assigned a value of 5. It doesn't change until you reassign that variable another value, right? This is different. This is a live, constant, dynamic connection. So anytime this changes as well. They are one and the same, okay? And these are super easy to do. Once you have this node editor up, I'm going to create a couple new objects here. So let's do this. I'm just going to duplicate, so we have 2 spheres in the scene here. And I'm going to freeze the transformation values. And clear this out and just add those 2 spheres. Shapes, by the way, it will always show shapes unless you turn that option off. We don't really have to worry about those. We're just concerned about the transformation nodes. So we could, let's see, p-sphere 2 is this one. It's the one on the left. P-sphere 3 is the one on the right. So let's rename these. I'll call this the control sphere and follow sphere. And I'll expand these. Hotkeys, by the way, 1, 2, and 3 for the different levels of expansion when you have these selected. So 1 just collapses it just to the node itself. 2 will show all connected, and 3 will show all available attributes. Okay, so you know, let's say we wanted to mimic the exact same transformation values. I could expand translate for my control sphere and for my follow sphere, and I could connect these straight across. So it's as easy as clicking on the output node and dragging, and you'll get this wire, and I'll drag over to the attribute that I want to connect with. Okay, and it's important to know when I drag over to this follow sphere, you can see a lot of them become grayed out. This is showing me attributes that I'm allowed to connect to, basically values of the same type. You know, in C# you wouldn't be able to say, I want to assign this integer value string, right? That wouldn't make sense. This is the same thing. Translate y is a float value. I can't assign it to a multivariable matrix, for example. So this makes that really easy. I can attach to translate x because that's also a float. Yes?
So since you just put translate x to translate y, if you move your first sphere, the x direction is going to move this second one.
Yeah, I mean, that's the cool thing about the node editor is there's like no rules. As long as they're the correct type, you can assign anything to anything. Right? So just to make it really simple, if I just connect straight across, translate x, translate y, translate z, then as I move control sphere, let's bring up the channel box here. As I move control sphere, right, the other sphere is getting the exact same values. So what do I have? 0.8, 6.3, and negative 2.6. That's my values for my control sphere. If I click on the follow sphere, they're the exact same values, okay? And you'll notice there's also these yellow bars. That indicates that there is a direct connection to something. Okay, you remember with constraints it gave like a blue bar, right? That's an indication there's a constraint. A yellow bar is a direct connection. Okay? I can really easily, I can delete these. You can just select the one or ones that you want to get rid of and just hit delete. Right? That connection is gone. But yeah, Daniel brings up a great point. I don't have to connect x to x. I can connect it to whatever I want. So let's say I'll connect translate y to translate y. I'll connect translate x to scale of y. And I'll connect translate z to rotation. Oops. Expand that. Oh wait, translate y to, or translate z to the rotation. Let's see if I scale in y. Let's do translate x. Okay, and sometimes it has to put these conversion nodes in there. It's transition, rotation, and translation use. They're still floats, but it has to translate values to basically 360 degrees is what it's doing, right? Linear values to degrees. So if I play around with this now, what we did, y was, wait, let's reset these back to 0. Right, so, right, it's squished. That should make sense though, right? Because I connected the z value, or was it the z value?
X, I think.
The,
Maybe Z.
I can't remember. Translate, or scale y was connected to, well, let's look in here. Yeah, to the x value. Right, so translate y, those two are connected. Translate x, you can see is connected with the scale. And translate z is connected with the rotation. Right, so you can see you can get, here's some really crazy behavior now. Right? And all I'm doing is playing around with the translation of one object. So you can get some really crazy effects, but obviously some really advanced, complex connections built up here in the connection editor. Okay. Does that make sense? Direct connections make sense? Okay. So along with direct connections, we also have a whole bunch of, they're called utility nodes. And let's see if I can remember how to show the create panel. Create tab, there it is. Tools, or tab, create tab. Nope, that wasn't what I thought it was. Well, we may have to be in the hypershade for you guys to see this. Let's do that. I'm going to open up the hypershade. You've used the hypershade, yeah? Okay. Here's the node editor. This one right here is the node editor. It's the exact same thing. Okay. So here to the left of the node editor is the create panel. So far you've probably mostly just used this for texturing, creating shaders. But there is a lot more available in here. There are not like 200 different shaders. There are also a ton of different utility nodes. In fact, here's a filter here on the far left of that panel. You can click on utilities, and here are a number of different utilities. Okay, just like you can connect basically any matching attribute type to any other attribute. These utility nodes were created for a specific purpose. Most of them for like texturing, but you can use them for anything that will accept the same value type. So I'm looking for one specifically here that's called reverse. Okay? And a reverse node, essentially, it's just performing a math operation. And you can find these things in the documentation. We're going to put in an input value, okay, and it's going to do this calculation. It's going to say 1 minus the input value equals the output. Okay? So if I input a value of 1, this inverts it to a value of 0, right? So 1 equals 0. If I input a value of 0, those math brains going, this is a really complicated algorithm, I know. But, right, it gives you a value of 1. Right? So between those values of 1 and 0, it allows you to quickly invert those numbers. And this works anywhere in between, right? If I put in a value of 0.6, we'll spit out a value of 0.4, or 0.5, 0.5. It will always give you the other half of that equation. And this is really useful for targets. I mentioned blending between the two. If I have one target set to a value of 1, I want the other one set to 0. Right? And as I come down, let's say I get to 0.6, this one's going to come to 0.4, and as I get to 0.3, the other's going to go to 0.7, and then the one's going to get to 1, and the other will reset. Right? So this will allow us a really easy method to blend between those two objects. Okay? So I'm going to, let's just delete that reverse node, close this. We don't have a create panel here, but when you're in the node editor, if you hit tab and you start typing in a name, reverse, you have access to all those nodes. You just kind of have to know what they are. Difference, right? So I go to reverse and create that reverse. So we're going to do this with controls, obviously, when we actually create a rig, but let me just quickly show you how this works. Let's come back to, do I want to delete those? No, I'll just leave them here. Let's come back to this setup we had before, right, where we've got this cone that is constrained between the sphere and the cube. And I'm going to reset their transformations to the value of 1. And for the sake of argument, let's just put a control in here. I'll create a circle. We're not doing any parenting or anything. I just need something in here to show you how to do this. So there's a control. I'll just call this control. And let's delete history and freeze transformations. Where am I looking? There we go. Okay, the objective here is I want to have an attribute on this control that I can say follow this one or follow that one. A single switch, right? In this case it would be IK or FK, a value of 1 or a value of 0. Or in this case it's going to be, do I follow the square or the cube, or do I follow the sphere? We haven't talked about custom attributes yet. By default, all I get is the transformation values and visibility, right? So if I want to add another one, I just come up here to channels, edit, add attribute. Okay? And I'm going to give it a name here. So I'll just call this switch. Okay, and we have to give it a data type. So vectors you probably won't ever use. Integers, that should be fairly clear, right? 1, 2, 3, 4, 5, 6, 7, no decimal points. Floats are decimal points. A Boolean is a switch, true or false. Okay, and in enum, this allows you to create a list of options. In this case, by default, every single time you select this, it puts in green and blue, and you have to go and change it. Okay, but if you wanted a list, if say you had multiple objects, cube, sphere, torus, you wanted to create a list of different parenting options, you could create an enum list. Behind the scene, this is just an index, by the way. Green is a value of 0, blue would be 1, and so on and so forth, the more you create. Just an index with a string value attached to it.
So that show up then in the node as a connection option?
Yeah, here, let me just click add really quick. So here's my new, I called it switch, right? And now I've got these two values that it generated there. So I want to do that. This, I want to be a float value. I want to be able to blend between the two. So if I do an integer value, it's just going to snap 1 or 0. But I want to be able to blend, so I need a float value. So I do a float, and then I can set a minimum and a maximum. So a minimum should be 0. I don't ever want it to go below 0, and I don't ever want it to go above a value of 1. Okay, default, whatever. We'll just leave it at 0, and I'll hit OK. Oh, I have to have my object. What did I do wrong? Oh, the name got erased. Switch. Okay, and now I've got this new switch label, this new attribute, and I can click and drag that, and I get a value between 0 and 1. That does nothing right now. It's just an attribute. Okay? So I'm going to clear the graph, and let's bring the control in. So I've got the control selected, and I'll hit the plus. And let's bring in the constraint. I'll have the plus on that too. And I'll expand these. Okay, so the objective here is when that switch has a value of 0, well, let's go to 1 first. When I have a value of 1, let's say I want it to follow the cube. Okay? When it has a value of 0, I want it to follow the sphere. So there's obviously going to have to be this kind of inverse nature of the values that we put into those target weights. So at a value of 1, right, we're going to follow, what did I say, the cube? So my cube weight at a value of 1 should be what?
1.
Should be 1, right? And my sphere? It should be a value of 0. Okay? So when we have 0, we expect it to follow the sphere. Right? And we're going to have this inverse nature. So the cube should have a value of 0, and the sphere weight should have a value of 1. Okay?
Those are the IKFK.
So this would be similar to IKFK. Exactly. Yep. So one of these I can direct connect, and one of them I have to reverse. Okay? Does that make sense? We've got to invert a value here. So if we take a look, whoops. If we take a look at this, a value of 1, I'm following the cube. Cube is a value of 1. These match up, right? Let's see down here, I'm following the sphere. It's a value of 0. The cube is also turned off. So this value and the attribute value and the cube, they're exactly the same. I can directly connect these two attributes, right? Whereas the other target, the sphere, is always inverted from that switch attribute. It's always the opposite. So if we come back to the node editor, we can replicate that same behavior. So my parent constraint, down at the bottom of my parent constraint, close to the bottom anyway, I've got these, here's my weight values. They end with that W and then a number, which just is, it starts at 0, it's just an index of the weights, right? So the switch again should be 1-to-1 with the weight of the cube. So if I take switch, right, this is on my control, I take my switch attribute and I will connect that directly with the cube weight. Okay, let's back out here and I should be able to verify that. So there's the constraint. Okay, I've got that yellow bar again to indicate a direct constraint with a value of 0. If I look at my switch, right, I've got a value of 0. If I turn this up to 1, see that? Wow. All right, look at my constraint again. You can see that that value has now updated to 1. Okay, we good so far? Okay, so now again we have to do this inverse value for the sphere now. Okay, so again, let's get back to that reverse node because that's going to do exactly what I want. Right? That value of 1 will be transitioned to 0. So I'll hit tab and I'll type in reverse. Let's expand this. Okay, a reverse node will allow up to 3 values. You do not have to use all 3 values. We'll see this a lot with different tools we use because they're often used for like XYZ values or RGB values. But you don't have to use all 3, and often you'll just use 1. Okay? So we're just going to use the input X channel. That doesn't mean I'm inputting an X value. It doesn't have to be an X coordinate. That's just the way the tool is phrased. Okay? So if we start with X, if we input into X, we need to output the X value. If you input into Z and you output the Z value, did I say that wrong? If you input into X and you output a Z value, it's not using your input value for that calculation. So I'm going to take my switch and I'm going to output that and plug it into the reverse node input X. Okay, I can have as many outgoing connections as I want from a single parameter. But obviously you can only have a single input. Okay, so I output my switch, I put it into input X, and somewhere magically between this label and this output label, it does its math equation and spits out the answer. It's magic. Okay? I don't know how it's done. Wizardry. So right now I have a value of 1. It inputs here. It does some math. 1 minus my input value 1. So now my output X will be 0. And I can output this and plug it into p-sphere weight. And that will invert my value. Okay, so again, if I close this, we can verify that here on the parent constraint. You can see those values are now inverted. And now from this switch, as I alter the values, you can see I get that nice blend between the two transformations. So again, if we were to say like this cube was our FK system, and I animated it, and I did all this fun stuff, and then I knew that I needed this IK hand to be planted right here. Okay, that for my next sequence of animation. And I get my FK system in a position that I'm happy with, and then I switch between the two, right? And that blended system will come to land where that IK target system is. Did I lose anybody? Nod? Yes? Okay, where did I lose you?
It makes sense, but I just, I don't know. I think it's just like a matter of how.
Okay. Does the constraint part make sense? The targets, the parents, the weights, does that make sense?
Yeah.
Okay. Does direct connections in the node editor make sense?
I think it's
That's where we're getting a little fuzzy. Okay, Kim?
We were just looking at this. Yours seems to blend a lot smoother. How did you, like mine doesn't like go in between.
Your snaps.
Yeah.
I mean, look at
I probably just missed this step.
Oh, it's okay. That's just the nature of when you drag on the channel box. If you click on the link, and it'll export and it slides. Okay.
You can keyframe the switch. Like
Absolutely. Yeah, you could keyframe that switch. Yeah, here, a value of 0. I'll just key selected. Right, I'll move this wherever. Value of 1. Key it again. Blend between the two. Yep, that is a keyable attribute. Okay, so we're kind of getting lost on the connection part then. Right? Yeah. Does the idea, no, forget about the revert, forget how I hooked up the constraint. Does the idea of a direct connection make sense? Okay. Does the reverse node make sense? What it's actually doing? If you just had the reverse node, does that make sense what it's doing? Okay. So then it's just combining everything together that we're getting a little confused. Okay. Well, figure it out. Just kidding. Let's just start over. Okay, in the node editor, all I did, it was just a sequence of direct connections, right? Is this what lost you here? Was this confusing on the board? This is a little confusing? A little bit? Okay.
So this
I think maybe we'll just change the terminology a little bit. Yeah.
So doing all these nodes is just giving us a way to control whether it's done an IK animation or an
whether, well,
Or something that you
here,
need.
let me show you how it actually works. How about I do that? Here's what I'm going to do. I'll create an arm. And let's orient the joints really quick. Let's do it like that one. Y. Okay, just a quick orientation there. Got some joints. And I'll give these names. So this will be ARM FK01 joint. Okay, so this will be my FK system. And I'm going to just put this in a group so that all of its transformations for the shoulder, the values will be the same in reference to that parent group rather than the world, because I'm going to have to make a couple more of these. So I'll just put it in a group. I'll call this the FK joint group. And I'll duplicate this 2 times. And then I'll rename one of these to the IK group. And then this is going to be a new term for you, but we're going to call the one that blends between the two is going to be called the RK for receiving kinematics. Okay, we've got forward, inverse, and then this is RK for receiving kinematics. Okay, and I can just do a quick search and replace for these names. Under modify, search, replace, and I'm just going to replace all of the FK strings for IK, and here I'll do the same thing for RK, just to get my naming conventions correct. And then I'll take my groups, not the skeleton themselves, but the group for the IK system. I'm just going to move that off to the side. Okay, the FK system, I'll move this off to the side. Okay. Normally, obviously, your shoulder is going to be the same place on your body. So these would all, when you start, these are all going to be in the exact same position. Okay, but so that we can see what's actually happening. Because I used groups to move them around, the values on the shoulders should all be exactly the same, right? Because that's in relationship or in reference to the parent group, right? But other than that, other than right now the positions of the parent groups, these 3 joint chains are exactly the same. I'm not going to put FK and IK systems in right now because we don't have time to do it. But we will work on constraints. So the way this would work is exactly the same as having that cube as a target and the sphere as a target for the cone. And instead we're going to have the FK system as a target, the IK system as a target for the receiving system, the RK system. Okay? So I will click on the FK arm 1, IK arm 1, and lastly IK 1. And I'm going to add that parent constraint. It will shift because I've got offsets turned off, so it moves it right into that middle position. That's okay. Okay, I'll do the same thing for the elbows. FK, IK, RK. You don't have to go in the same order every time, but I would highly suggest it so that your targets are going to look the same. Okay, same thing with joint 3, FK, IK, RK. I'm pressing G for redo last command, which was a constraint, right? And so now I've got these 3 constraints under the RK system. Each of them will have the FK and the IK targets as weights in the system. Okay? You're cool with that? All right. And you could obviously play with these as well, just to verify they're working, right? All right, so the shoulder joint is blending between IK or FK. Why isn't the elbow joint going with it? It's part of the hierarchy.
Because the elbows are constrained.
Elbows are constrained. Right, and constraints have priority over hierarchy. Okay? Okay. So I'm just going to build a control in here really quick like I did before. So create nerd circle. Let's just put it up here and make it really easy to see. I'll call this control. And again, I'll just delete history and freeze my transformations. Let's hide the grid while we're at it. Okay, and again, I'm going to add this attribute here to switch between the two. This time I'm going to, this is how we'll do our IKFK switches. I'm going to call this IKFK. If you want, you could call IKFK switch. I'll call it IKFK switch. That way it'll make a little more sense. Okay, again, this is a float value, okay? Between 0 or 100%, or a value of 0 to 1. So my minimum is 0, my maximum is 1. And I'll hit OK. And that has added that IKFK switch to my channel box. Okay? Now, I'm hoping maybe just changing the terminology and renaming everything will help this. Okay? So if we get to a point where I've lost you, stop me. And let's cover it. Okay? Now, when I create an IKFK switch, the order that I write that, I make that important in my head. Okay, that attribute goes from 0 to 1. We know that. We set a minimum and a maximum, 0 to 1. Okay? So I always think 0 is the low end, it's to the left, right? 1 is to the right end, it's to the right. My min and max value. I wrote my attribute IKFK in that order. Okay? So when I look at that attribute, I think same thing. When it's set to a value of 0, I'm in IK because that comes first. When it's set to a value of 1, it's in FK because that comes second. Okay? Is that, no, okay. Is that, I mean, this is just something I do. You don't have to do it that way, but this helps me to keep things consistent every single time I make this. Okay? So IK, the IK system is on, by the way, when it's a value of 0. Does that make sense? Okay, but that's what it is. IK is on, value of 0, FK is on with the value of 1. Okay? Sorry? The order that we actually do the constraints doesn't matter at all. No, that doesn't matter at all. It all comes down to how we plug in the values of this attribute into the weights. That's all it is. And obviously it would get more confusing if you didn't have a good way to keep track of it. So again, I would highly suggest, let's just do IK, when this is a value of 0, IK system is on, when it's a value of 1, FK system is on. Okay, that makes this a little bit easier. Okay, so we're gonna have some target weights here. We're gonna have our FK weights. We're gonna have our IK weights. So if we just think about the FK system right now on this switch, okay, we're only thinking about FK. Right now we know that when our IKFK switch is a value of 1, the FK system is on. Okay, we defined that. So I don't even know if that makes sense. 1 is 1. 1 means on. Right? 1 is on. 1 is on. It's on. It's just on, you guys. I don't know how else to say it. 1 means it's on, okay? So when this is on 1, when this is a value of 1, then in order to turn, okay, there we go. In order to turn the FK system on, it also needs a value of 1, right? So the switch is on, the target is set to 1. When we want this system, the FK system off, we change the IKFK switch to a value of 0. Okay, and we turn the FK target off, which is also a value of 0. Okay, so we've got a 1-to-1 relationship here. We cool with that? Okay, So when we just think about the IK system now, okay, when the IK system is on, excuse me, when the IKFK attribute is set to a value of 0, the IK system is turned on, right? So it's set to a value of 0, IK system is turned on, which is a value of 1, right? If it's on, it's turned to 1. That make sense? I kind of lost you, Rhett. I saw it. I lost you, right? So again, we defined here the IKFK switch. When it's set to 0, the IK system is on. When it's set to 1, the FK system is on.
So if you change it to 1 down here.
They're just numbers. You guys think about your computers. You've got this little thing on your computer. They always put this little button on there. Or you know how transistors work. They're always a value of 1 or 0, or a switch. Right, it's a switch. It's 1 or 0. It's just a switch. This switch allows us to go kind of power it off. But really, it's just a switch. 1 or 0. Right? So, yeah, essentially, if you just thought of this as a little toggle switch, right? When I flip this down, I'm turning, I have to send some value back to the system. It's sending back a value of 0. Right over on this side, it's sending it back a value of 1. Which is, if you guys have seen that on your computer, that's what it is, by the way. It's a 0 and a 1. It stands for power. Did you know that? No. That's what it is. What? Right? I know, I learned that like 5 years ago, and I said the same thing. Okay. So again, when the IK system, or when this IKFK attribute, the switch is turned to a value of 0, the IK system is turned on, right? So here is my value of 0. My IK system has to have a value of 1 to indicate it's been turned on, right? When this is a value, my IKFK switch is a value of 1, I've turned the FK system on, which means my IK system needs to be turned off, right? So when I have an IKFK switch value of 1, my IK system needs to be turned off. It's a value of 0. So this is an inverted relationship, right? This is where that reverse node comes in handy. Okay? Do these relationships make sense? And don't lie to me if they don't. I'll keep trying to say the same thing over and over until I find another way to say it. Does it make sense? Okay, okay. Okay. So again, one-to-one relationship. This is a reverse or an inverted relationship. So if I take this switch, right, IKFK switch, I can plug this value, because it's 1-to-1, I can plug it directly into the weights of the FK system. Right? It's 1-to-1. Exactly the same. I always make that hard for you to see, don't I? Sorry. I can't plug it directly into here because then I won't get that inverted nature of my values. So this is where I have to introduce some way to reverse those values. That's where my reverse node comes into. Right? And this does exactly what we need here. This value of 1 will be changed to a value of 0. A value of 0 will be changed to a value of 1 within the reverse node. And then you're going to take the resultant output and you're going to plug it into your IK system. So this is just doing the math for you. It's inverting these numbers from the IKFK switch. Okay? Is that better? We still lost? Anyone still lost? Okay. Let's do this then. Let's pull up the node editor again. Let's get rid of all this. Yeah, GDC, by the way. Any of you guys played that new Spider-Man game that Insomniac did? So they spent a while talking about Doc Ock. His skeleton was over 800 joints. I think 700 or 680 of them were just in the tentacles themselves. that rig, so what I just had in here, can I bring it back? I can't. Let's just graph all of these, just for funsies. Okay, that's all my inputs and outputs just for those 3 joint chains I have in there right now. He had over 150 nodes. Sorry, 150,000. Sorry, that was very different. 150,000 nodes in his rig. It's intense. These will get, the more you rig, the bigger these graphs will get. They start to get really crazy. And if you ever want to impress somebody, that's what you show them. I rigged this, and they're like, oh, that's cool. And you're like, yeah, this is how I rigged it. And they go, oh my gosh, you're the smartest person. I show my mom all the time. It feels so good. Okay.
What's on her fridge?
What's that?
That's what she puts on her
Yeah,
fridge?
she puts hypergraph. Yeah, she puts node editors on her fridge. Yep. All right, so let's connect these things up. We need the control, because that's where my IKFK switch is. So I'm going to load that into my node editor. I'm just going to take the control shape off. I don't need that. So I have the control, and then I need the constraints, where those target weights are. Well, let's just deal with one of them right now. I'll just bring in the first one. Okay, select them both. I'll hit 3 just to expand them. And let's blow this up a little bit. Okay, so we're going to go back to what we had on the board. IKFK switch has a direct 1-to-1 ratio with the FK system, with the weight of the FK constraint. So we can just hook that straight in, a direct connection. So IKFK switch, right, here's my weight values. So output from the control IKFK switch directly into the FK weight. Right, this is weight 0. That doesn't matter. The number you add them again, it doesn't matter at all. Okay, it just needs to be attached to the FK system. So I bring this down a little smaller, and we can see that right now I've got a value of 0, which means the FK system is turned off, the IK system is turned on, so that's why this joint has snapped over to the IK system, right? This is the IK joint chain. So now we need to connect the IKFK switch up to the IK system, which again, that's an inverted relationship. So I'll press tab, I'll type in reverse, introduce that reverse node. Right, and I'm going to take that same value from the IKFK switch. I'm going to add it as input. Okay, input X. It's going to do its magic math and spit it out here into the output X. Again, you got to use X both times. That's where it's doing the math. I'm going to take my X value, my now inverted value, and I'm going to plug that into the IK system. If I put it into X, then I need to take it out of X. That's all it is. I could put it into Y if I wanted to, but then I need to make sure I take it out of Y. Okay?
So it just has to go in and out the same.
Exactly. The same channel. Yeah. You mean initially when I did it? If you had set, I had left the IK value at 1. So when I turned the other one off, then it made, when I turned the FK value down to 0, then it automatically just followed the IK value. Under the constraint? FK is 0. IK is 1? And it didn't snap? Is maintain offset? Did you leave maintain offset on the constraint? So that needs to be off. Yeah. So in that case, you just delete your constraints and remake them. Yeah. So now I should be able to change the switch between 0 and 1, and we'll see that joint. Can you see it?
Yeah.
Right. You can see it blending between those two systems. Oh, you see it up there too. Okay. Right. So really, I could go through this exact same process, right? For all 3 joints. Well, there kind of is. So each one of those joints has its own parent constraint, right? But the IKFK switch, that same switch and the reverse node can work for the whole arm. I don't need a different reverse node for each joint, right? That IKFK switch, I want that to control the IKFK system for the whole arm. So if your question is, do I have to create an IKFK switch shoulder, IKFK switch elbow, IKFK switch wrist? The answer is no.
It's gonna go from left to right.
Exactly. So if I bring in my other constraints, so here's 2 and 3, we'll load those in. I can actually just get rid of this one. I'll just hit the minus button. And let's bring over 2 and 3. Press 3 to expand those. Let's blow this up again. So again, this is the same IKFK switch. I want it to affect the entire arm. Okay? And I should probably put this in right now. When we do these systems, we're going to do one per limb. So you won't have one global IKFK switch that changes the entire body at once. You'll have one for the right arm, one the left arm, one the left leg, one the right leg, because you never know when you'll need one or the other, right, for your different animations, right?
Like
But
just one arm is like on something.
exactly, and you want to swing the other one, right?
It's a bunch of stuff.
So for right, but I mean, this makes sense. We do one IKFK switch for the whole arm, okay? So again, we're driving it with the exact same attribute. And these rules still apply. When it's set to a value of 1, your FK system is on. 1 to 1, it's exactly the same for these constraints. When it's a value of 0, our IK system is on, and we've got that inverted relationship. So IKFK switch, I plug that directly into the weight values for my FK, there it is, FK, targets, right? So I can do that for both constraints. Yes?
So you have your 0 and your 1. So basically, is it just a common rule that whatever is your 1, you've got to reverse it?
For an IKFK switch, yeah.
Yeah.
Uh-huh. Yep.
Okay. That makes it easier.
We'll do some other switches where we'll have multiple target. Well, never mind. We'll get to that later. But yes, essentially that's correct. Okay. Yeah.
So with this, just with the control, you can send out as many channels as you need.
Yep.
They just can only receive one.
Exactly. Yep. Send out as many as you want. Let's make this maybe a little more readable. Okay, you follow so far? So I'm just doing the exact same thing, right? Just with 2 at once. So the IK, again, those are inverted values. So rather than taking directly from the IKFK switch, that has already been connected into the reverse node. I just need to take my output now and put that into my IK values. Okay, so the exact same connection for all 3 constraints. So now if I play with this switch, you see my arm will blend back and forth between the 2 systems. So if I took, this was my FK arm and I repositioned this, and I moved it over here, and I wanted to blend it, it does weird things, by the way, if your transition is too extreme, because it's just doing a linear translation from this point to that point, so that the joints will kind of, if they're not really close, you'll get some weird manipulation in it. So you get them close and then you blend.
Why does this shoulder still switch? I thought you deleted like that.
I didn't delete the node, I took it out of the node editor, just so it wasn't viewable in the node editor, but it's still there. Right, and obviously if this were the FK system, I could do the same thing, and I'm blending between the 2 systems. Okay, does that make sense? Think you could replicate it? So I'll tell you what we'll do on Thursday. Thank you. We're going to build this, but between now and then, I want you to build the systems again. So pull up the old lamp. You can use the one that I had, or you can use your own lamp. I don't care. By now, you should be able to recognize some of the issues we had with IK systems. If your lamp isn't modeled perfectly straight. In fact, just use mine so we don't run into that issue. Should be available in files, okay? You're going to create 2 separate joint chains. So create one joint chain for FK system and put an FK rig in there. You can duplicate it. You don't have to create it new. Duplicate the system so you have the exact same orientation, position, rotation, everything. Duplicate it and create the IK controls. Okay?
Basically, just have an IK control on the like the head and the like where the lamp connects to the base, right?
Yeah.
So those are the IK.
Yeah, just do the yeah, exactly. Sorry, I know you guys gotta get out of here, so do I. So we'll have a base, you have kind of that lower part of the arm, and then for the head. So really just those 4 joints. Right, your IK system will go just like we did before, just from the base of the arm up to the head. Okay? So again, 2 joint chains. Just make the one first, orient it, get it so it's all right, and name it FK, and duplicate it, rename it to IK. You don't have to reorient anything, just use the same chain. Just like I did in this example. Okay? Well, I should stop this recording. Bye, Kyle.